In this final video from chapter 11, we'll talk about how we actually form memories. And we'll talk about a process called consolidation and then reconsolidation, which is going to be consolidating again. And we'll talk a little bit about whether this process can be enhanced. So consolidation is the term that we give for the neurobiological change in our memories from when they're new to when they become stable over time. And this is going to refer to any number of chemical changes that occur um, to our brain that go from that initial learning, right, to a long-term stable memory. It turns out that there's an initial process of consolidation that occurs for about 5 to 8 hours. Okay, it's enhanced with sleep, by the way. So if you learn something new and you go to sleep, this consolidation process sort of ramps up. But there's a lot of chemical changes that occur within the 5 to 8 hours after you learn a new thing or experience a new thing. Okay? Memories are very fragile during consolidation. They're particularly fragile during that first day, right? So if I learn a new thing now, and then 2 hours from now, I learn something related to it, right? Then that my first memory of the thing can change. That makes sense. And they're also still changing for a few years, it turns out. So our memories become more stable over time. It's because they're not fully processed, they're not fully locked in. Over time, it takes a process, and that process is called consolidation. Now, the hippocampus must be involved here, right? Because we know the hippocampus is involved in forming new explicit memories. And so, what is the role? Well, there's a lot of debate about it, about how long the hippocampus stays involved and how memories are represented over time. One general idea is that the hippocampus becomes less involved over time, as evidenced by the idea that HM could remember his childhood, right? And so he has consolidated memories that aren't stored in the hippocampus, right? So maybe the hippocampus is more involved early on during consolidation, and then the representation of that memory spreads out kind of in a network to other parts of the brain where it's actually kind of stored longer term in our general knowledge or personal knowledge. Okay. Now memories aren't just transferred like a movie, right? They change in quality, right? So what might be an episodic memory can change to a semantic memory. Like I remembered that I went to Disney World, but I don't remember the events very well anymore. That kind of thing happens all the time. And then the network of connections might become more diffuse or might connect to other things, right? I might mix up, Disney World and Disneyland, that kind of thing. So we got this bigger change over time. One demonstration that consolidation is a process that takes time is that you can do any number of things to disrupt consolidation, and you can test out the time frame for consolidation, right? So we know, for example, that a concussion leads to retrograde amnesia. We forget the moments or hours before the concussion, but not anything back, right? Another effect on the brain that causes that kind of retrograde amnesia is electroconvulsive shock therapy. So people who get um, electroconvulsive shock therapy, which is electrodes put on either one or both sides of your brain to cause seizure activity, it's a treatment for depression and other disorders that is still used to this day. We'll talk about that in a later chapter. One of the consequences of having ECT, electroconvulsive shock therapy, is that it causes amnesia. It causes retrograde amnesia. And you can test the length of that amnesia in this clever study from the 70s, where they asked people about TV shows that only aired for one season. So this was before the time of Netflix, right, where you could get this show forever, right? These shows were only on for a season, and then they didn't really have reruns, that kind of thing. Show never came back, right? So they tested people on their memory for the names of TV shows, either fake shows or real shows, right? Um, and what they found was that um, giving people electroconvulsive shock therapy caused them to forget the shows from this year and last year and the year before. But it didn't cause any forgetting for shows from further beyond 10 years, 8 years, 6 years. Okay? So it seems as though that shock activity disrupted memory, but only for memories that were not fully stabilized, right? Not fully consolidated. So in the last couple years, right, those memories are still being consolidated. They're still being locked down in the brain, and that disruption can cause difficulty recalling them. Pretty cool, right? You can demonstrate this with animals as well, right? So um, teach them a maze, right? Disrupt their brain activity, um, and then time out how long it is before that disruption doesn't have an effect anymore. And then you know that consolidation is done. That's how we've gotten that 5 to 8 hour window. That's how we know that there's still some consolidation going on for some time after that as well. So what is going on in consolidation? Because this is kind of a general term about chemical changes, right? Well, one of the more specific ideas is called long-term potentiation, or LTP. Essentially, the idea here is that our synapses are going to be critical to this consolidation process. So under a normal situation, we've got um, neurotransmitters in synaptic vesicles that are being released into the synapse, right, and causing activity on the other side, right? So a certain amount of neurotransmitters activating a single receptor here, and then you get a little bit of activation at the synapse. Long-term potentiation is the idea that changes at this synapse is going to increase activity when it's potentiated. Okay, so you see a few changes here, right? So more neurotransmitters presynaptically, more neurotransmitters then released into the synapse, and then more receptors on the other side. So this is two changes, right? More neurotransmitters being released, more receptors on the other side. And so the same activation leads to more synaptic activity or stronger synaptic strength. Essentially, neurons that fire together wire together, right? So because this was activated, it's potentiated, right? We get some feedback here. We build more receptors. We create more neurotransmitters on the presynaptic side. Okay. So breaking that down, we've got increased synaptic strength at certain synapses. They're the synapses that are activated, right? So when I learn something, it activates synapses. Once those are activated, the synaptic strength can increase. Get co-occurrence of activation here and here. These are long-term changes, which we learned back in chapter 4 are called metabotropic changes, right? So it's not just that I've released an ion, ionotropic, but this activation caused metabotropic changes to the neurons themselves. Okay, the synapse changes, it's now different. It's now potentiated. This takes time, right? And is supported by sleep. So um, this activation is going to cause a cascade. This co-occurrence of activations causes a cascade of chemical changes that build up this connection for later, but it's not going to happen immediately. And so that's why consolidation takes some time. Now you can imagine then this is a single synapse. Any individual experience, like learning that learning that the sun is 93 million miles away from the Earth, right? A variety of synapses are involved in that fact. And that fact then is connected to other facts, right? And so there's going to be a network of these changes, not just a single neuron. Okay, so we want to think many synapses, not just one. What's super cool about consolidation is that it doesn't just happen once. Researchers have discovered and coined a phrase called reconsolidation, where it turns out that every time you retrieve a memory, it goes through the consolidation process again. We temporarily hold anything we remember in short-term memory, right? Like, I remember how far the Earth is away from the sun, 93 million miles, right? That's now in my short-term memory, right? Because I just thought about it. And it's then going to be susceptible to that consolidation process once again. So I can now remember something about George Washington that I learned in first grade. Um, I'm going to reconsolidate that memory based on the context around me. We can demonstrate this in the same way that we demonstrate the consolidation process, right? Because I can disrupt it. Post-traumatic amnesia occurs for these kinds of things. So if I am discussing something and then I have a concussion, that can affect my memory for that thing. If I have electroconvulsive shock therapy, that can affect things. If I damage the brain of a rat, that can do things. It's also susceptible to other changes. It doesn't have to be trauma, right? Other thoughts build context, right? So exposure therapy works in this way, where in order to reduce a fear response to spiders, I need to expose myself to the idea of spiders, right? So I pull the memory back up and I process it in a different way. In CBT, reappraisal works this way. So think about your ideas about your relationship to your parents or your thoughts about yourself. Bring those back up into memory. And now I have a chance to think about them differently. Physiologically, I'm starting the consolidation process again. So now my memory of like who I am and my self-confidence and that sort of thing is susceptible to changes, just like it was when I learned it in the first place. That's the idea of reconsolidation. So it's a chance to change our minds. How can I prove this, right? So clever research is basically the idea, right? So um, we can demonstrate consolidation by disrupting it, as we mentioned before, right? And there's a drug called anisomycin that disrupts consolidation. So in rats, we can do fear conditioning, right? Tone, shock, tone, shock, tone, shock. And what you should see in a rat is that once you've done this fear conditioning, they'll consolidate the memory, and when you play the tone, the rat should be afraid of it. But if I disrupt that process with anisomycin, the rat doesn't learn to fear the tone because the memory doesn't get consolidated, it fades away. Right? So this proves that within a period of time, I can disrupt consolidation and the memory won't be formed. Cool? So that's disrupting consolidation. As I mentioned, this occurs for a period of time, that 5 to 8 hour window, right? If I inject anisomycin on day 2, there's no forgetting because consolidation has already occurred. Okay, so if I inject anisomycin immediately, I disrupt consolidation. If I disrupt it on day 2, I don't disrupt consolidation because it's already occurred, or at least that initial process has occurred. And so the rat still remembers that the tone is scary. All right, so consolidation is a chemical process that can be disrupted by chemicals. There's a window for its initial process, right? About 5 to 8 hours. What I can do then to demonstrate reconsolidation is I can teach the rat to fear the tone on day 1. And then on day 2, instead of just injecting anisomycin, I can remind the rat that the tone is scary, play the tone and have it freeze. And then when it's reactivated, I inject anisomycin. And what we find is that when I do this, when I have the rat remember that the tone is scary and inject anisomycin, I disrupt reconsolidation and the rat no longer is scared of the tone on day 3. So reconsolidation can be disrupted just like consolidation can, which shows us and is consistent with human behavior as well, that remembering something allows you to make changes to that thing, right? There's a chemical process going on called consolidation that repeats itself when you remember. You can think of the implications for this, right? So if you want to change your mind, if you want to um, uh, think about the world differently, right? If you want to convince somebody that they were wrong and they should think about something new, if you want to um, go through exposure therapy, that kind of thing. One of the secrets to that, right, is pulling the memory back up and making it fragile again, allowing it to go through a consolidation process again, and now I can change it. Final thing to talk about just briefly, and if you're in my class, you've got access to these slides, and you can check all of this that you want to. But oftentimes when we talk about memory, a big question is, can I make it better? And first, the answer is yes, you can if you learn it better in the first place, right? So while we're consolidating, our memories are fragile, and as we're reconsolidating, they're changeable as well. So um, don't just get exposed to the information once, right? Work on it over time during that window before you go to sleep, and then bring it back up later and work on it again. So we've got control over our memories and what gets consolidated in the first place. So that's the real trick, is you have to work on it. There's a number of other um, attempts to enhance memory that are sort of biological treatments. Um, uh, some of them are called nootropics, which are supplements that people use to try to increase memory abilities. Ginkgo biloba, ginseng, multivitamins, glucose, etc., etc. Um, the research on nootropics is really weak, it turns out. We don't have a memory drug. We don't have a really solid memory drug, at least at the time of this video being recorded. A lot of the research is not well done. It's not well controlled. People show that, like, hey, you take this drug and compare it to nothing, and people do better. There's placebo problems with that, placebo effect problems with that. There's also the fact that some of these nootropics are stimulants, like caffeine, right? Ginkgo biloba is kind of a stimulant, right? So just being more attentive can help me remember things better, but that's not a memory effect, right? That's just a stimulant effect, right? And so, do any of these have specific effects on memory? It's not clear. So we don't currently have like a really solid, well-evidenced memory drug. People are working on it. The other thing people propose is that maybe your brain is like a muscle, and so if I train my muscle, my ability will get better. And so there's all sorts of brain training games, trying to train your long-term memory, trying to train your short-term memory through practice. The evidence for this is also not solid. Um, Generally, brain training games help train your brain for brain training games, right? So we get better and better at brain games, but the transfer of that ability to memory more generally is pretty weak. Like, so it doesn't necessarily help you remember people's names or remember your grocery list or do better in school necessarily. You kind of get better at the game. So the transfer effects are a lot weaker than they are for the direct effects. So that's a little rough. That said, cognitive engagement in general is good, right? So playing training games is engaging, but a bunch of things are engaging. So reading, playing Scrabble, socializing, playing games with your friends, all of that is cognitive enhancement, cognitive engagement. And so if brain training games engage your brain, that's good. That's better than nothing, especially as you age. But there are a number of ways to get that same kind of effect beyond, playing a specific memory game. So that's generally where the state of the art is right now with those kinds of brain training games. Finally, health factors, and this is where the evidence is quite a bit stronger. Cardiovascular health is linked to memory maintenance over time. So keeping your heart and your lungs healthy over time helps prevent dementia later on in life and age-related decline. There are also certain diets that you can look into where there's some evidence that they can prevent cognitive decline and memory decline over time as well. One of those is the Mediterranean diet. Um, you look into the specifics, but make sure, just like with the nootropics and the brain training games, make sure that the research is solid on these things. So just somebody just saying that this worked for me, or this diet makes me feel good, that doesn't necessarily mean that it's a memory enhancer specifically, right? It doesn't mean that there's a direct effect that we can evidence with real studies. So in terms of can you improve your memory? Yes, you can with work. And then we don't have a brain drug, memory drug right now. Brain training games might be good in that they're cognitive engagement, but maybe you can get that from other places. And then keeping yourself healthy, it turns out, is also good for your cognition in general and your memory as well.